Greetings folks, in this video I'm going to be having a look at the SpeedyBee F405 Wing Mini board. I have had a look at this before. I have done a full review and setup video and there'll be a link to that in the description of course. But Banggood very kindly sent this to me, so I thought I would do something a bit different. I'm going to use this board to run a roll axis gimbal for RunCam 2 4K. Let's just have a quick reminder. It's a really nice little board. It comes with Wi-Fi and Bluetooth. You can operate it using the SpeedyBee app on your phone. It has the USB board and beeper and all of that sort of stuff. JST-SH sockets for GPS and FPV gear, and comes with all the different connectors as well. You do have to solder on the pins of course, and solder on the battery cables and ESC cables. But anyway, let's go and have a look at the gimbal and I'll show you how to set it all up. So here we are on my Mini Talon. There's the little gimbal that I've made up just with a 3D printed front pivot for the lens, I guess, a little tray attached to the servo. This is a 180 degree servo, a TGY 1800 from Turnigy. Does the job well. We'll just turn the battery on. Let it do all its initialization, and there we go. You can see the camera is maintaining the horizon while the plane is banking around. Let's show you a little bit better this way, and it will go the full 180 degrees. So we'll get some good onboard footage when we get going, but for the moment we'll put the F405 mini board together and show you a few more details about the gimbal. I have done this in more detail, but I'll just give you a reminder of what you get in the box. Quick start guide overview there, and there's the main board there. You do have to solder on all the pins. There's the power distribution board, and we have to solder on power, battery and ESC cables. And here's the USB breakout board with buzzer and on-off switch and DFU button. And we also get a capacitor to solder over the ESC cables to reduce the video interference a little bit. A couple of alternative top decks or bottom deck or whatever you want to, and then all the different standoffs, all the different cables for connecting items into the different JST-SH sockets, and we get alternatively angled pins or straight pins. Alright, so we'll put it all together now and I'll show you how to set up the gimbal in iNav. Now, something that is essential with a new flight control board, especially if you're not used to soldering and setting up, before you do any soldering at all, connect it up to your computer, connect it up to iNav and update to the latest iNav version, just to make sure that the board is all working before you touch it with a soldering iron. So connecting up now, and USB has been recognized. Connect. So the board comes with 6.1.0 and I want to update it to the latest, so that's why it's gone straight to the CLI screen. So if we type in DFU, direct firmware upload, it will put the board into DFU mode. And now we go to firmware flasher, choose the board, SpeedyBee F405 Wing. Choose the firmware 7.1.2 and flash the firmware. Okay, we are good to go. Let's set it up as an aeroplane with a tail. At the moment with this version of iNav and a Mac, it just hangs here unfortunately, so we can just get out of there and we can see the animation is working. So now we go through our setup. We need to do calibration and all that sort of stuff, but I might wait until we've soldered it all up. Now, soldering up these little boards, I'll give you a few little tips. I'm no expert at soldering, but I have improved over the years. So yeah, use some sort of soldering flux to clean the pads, the soldering pads. It really does help, and it makes the solder flow nicely onto the copper pads, especially for the big battery and ESC pads. Now with these SpeedyBee boards, this is something I've started to do, is to pull out the VX pins in the S1 and S2 positions. So they would be where your ESC plugs in. If you're using an ESC with a BEC, then it's providing 5 volts onto those pins, and you don't need it. Rather than having to remove the red wire on the ESC, you can just remove these pins before you solder them in. Then I put all the pins in position, ready to be soldered in, and then I stab that into a little piece of foam board just to hold them in position. This is Depron. It's pretty heat resistant actually. It works very well, but that just holds the pins in position so they don't extract out while you're trying to solder them. And then once you've done all the soldering, make sure you go over it with a magnifying glass and make sure you haven't connected any pads where they shouldn't be connected with a solder splatter or a solder strand or something like that. And it's a good idea to use a smoke stopper when you're plugging it into a battery for the first time. That'll just cut out if there are any shorts. The soldering iron, make sure you have a tip that can touch the pad and the pin at the same time to heat them up before you apply the solder. That's a big thing. If your tip is too small, it can't transfer enough heat, and if it's too big, it won't touch the pad and the pin at the same time. And an adjustable temperature soldering iron would be good. I tend to solder my pins at about 360 degrees, and I increase the temperature to 400 degrees Celsius. This is for the ESC and battery pads. And clean the tip of your soldering iron regularly in between solder applications is a good idea. Sort of a front support with a 21.5mm hole, and I 3D printed that because it's pretty hard to drill a hole that big really. And a little bit of PVC plastic just sort of bent up like that, because you could 3D print the whole thing, I guess, but this is just an easier option for me. Gives this sort of angle a bit more strength than just a 3D printed part. So the Mini is just going to fit on the back there. This is just going to be a standalone gimbal. The board isn't going to be controlling a plane, so I don't need much power going into there, just enough to operate that servo. Servo will just plug in there. I have already calibrated the accelerometer on iNav, so now I'm just going to double-sided tape the board onto the gimbal. Arrow is facing that way, so I will need to, actually that'll all sort itself out when I work out the direction. I'm not going to be plugging in ESCs or receivers or anything else here. I'm just going to be using this to operate the servo, the gimbal, so that will end up plugging into S3, and we'll show you that as we configure it in iNav now. Alright, first off I'll plug the board in, might as well give it power as well. Connect. I have done the calibration. Outputs I need to turn on, enable motor and servo output. Save that. In the mixer. Now at the moment I don't have anything at all in the mixer. You would probably usually start off with an aeroplane mix like that, but I don't need that at all, so I'm just going to get rid of all of those mixer lines. I'll add a new mixer line myself, and I choose gimbal roll, and then we're going to play with this weight value here to get the rotation angle or the level angle of the camera to match the plane or the base of the gimbal. Oh, my mistake, that's put it onto S1. We actually want it on S3, so we may need to pretend we've got a motor there. With a normal 90 degree servo, I think I've had that up to about 350, but with my 180 degree servo, I think I was about 125, but we'll have a look at that. So we can save and reboot that. Now we go to modes, and we hardly need anything of the normal stuff here. What we do need is Do you need to arm the board? I'm not too sure, but we might as well just have the board armed all the time on channel 5. And we need to enable cam stab. Here we go here. Now we can just have it operating all the time if you just put the range all the way across, doesn't matter which channel you choose. We do have some servo action, but we need to increase it a little bit. See, that is not quite following the level. So let's go to 200 and see if we can get it to go too far. That's pretty good, really. I think that's about level. Yep, that'll do me. All right, so that's ready to put on a plane and take it out for a fly. Now, if you need to adjust the midpoint to level the camera, you can adjust in the outputs page. You can adjust this mid value here, and you can adjust the end values as well. So yeah, changing that will slightly tilt the camera in its sort of default position. Okay, here we go, trying the roll axis gimbal driven by the SpeedyBee F405 wing mini board on my Phoenix. Let's see how we go. Not a lot of wind. So we'll have to motor up a bit, but let's get an idea of how the roll axis gimbal looks. There might be enough to keep it up for a bit, or maybe not. But I bet that looks awesome up there. The wind's just disappeared a bit, turned a bit southeasterly. Let's just get a bit of height and see how we go. Not enough lift from the slope wind, unfortunately, so we'll just have to fly around. But yeah, it's a nice inexpensive little board, so perfectly good for using for things other than flying a plane, such as stabilising a camera. Well, it's doing pretty well. No lift today, so just have to do what we can do. So there we go. Roll axis stabilised gimbal always gives you a pretty cool view. Thanks for watching. See you in the next video.
The number you have dialed is not in service at this time.